Teachers Research Conference. I'm Julie Olson from Mitchell, South Dakota, where I teach science for our alternative school and dual credit biology. Today I'm here to teach you hopefully a little bit more about statistics, data analysis, and how to communicate that with your students. So within the chat right now, while I get the PowerPoint set up, I'd like you to type in some words that come to mind when you think about statistics, either for you or your students. Okay, so data collection and analysis in science research. I see a lot of terms coming in, and things from fear to I'm comfortable, the students need to understand more, high level, so things like that. And so I'm not here to show you how to show students how to collect data, but obviously there will be some ways, depending on your method of analysis, if you're using Excel or an online program. But again, today I'm going to show you how to do some simple statistical analysis. These are some Society for Science in the News, Science News and High School Educator resources that you can use that could be used for different topics. Some of them very timely, like the coronavirus. And so these are some of the things that I'll talk about. What I want to draw your attention to would be the t-test, which will give you a p-value. So I'm going to try to explain what kind of a t-test you would use in what situations and exactly what that p-value means. So p-value for high school students of 0.10 or lower is significant. Now, if you can get them to have it below a 0.05, that would be even better. I am also going to talk a little bit about correlation. So variation, you can do the standard deviation, and so sometimes the standard deviation is a little harder to explain, but if you use some of these graphs, we have a standard deviation of 1 versus 3. So it's basically saying how wide is the spread of your measurements. Obviously, you're looking for a lower standard deviation. When we look at p-values, it's basically how much do the data sets overlap? In other words, if I took a measurement in the green group, how likely is it to also be a measurement that I might get with the blue group? Obviously, the lower that is, the better. That means that your means are more significantly different. So we're going to show you how to do those p-values. So here's some different t-tests that you could do. You can obviously, I'm going to show you at the very end how to do a very simple lab called which tape is stickier. And this one could really develop into a nice project. So here's some sample data. We watered 3 sets of plants, 3 different sets of plants with different amounts of water every day. And so we have 10 plants. So 10's kind of the magic number. More is better. 30 actually is a way better number if I had 30 in each group. And so we want to know, is this different? So here's a simple mean, average, whatever you want to call it. But we need to know, are these groups significantly different? Is there really an effect of the treatment? So some of the things we could do, and this here's a nice little flow chart. The one thing that I'd like to explain would be what's the difference between independent and non-independent samples. So an independent sample would mean that I had a separate group of plants for group A and a separate group of plants for B. I didn't take my plants and give them 6 milliliters of water week 1 and then the same plants a different amount of water for week 2 or week 3. So for my plant analysis, I would do a 2-sample t-test here, okay, that 2-sample t-test. Now, if you're not real comfortable with using Excel, GraphPad has some free statistical analysis there. And so you can just enter your data and again, choose a test. So an unpaired t-test. Again, I have group 1. If I wanted to go between my 6 milliliter and my 8 milliliter, I want to see if those two are significantly different. I would use that. Again, they were 2 separate groups of 10 plants. Now, if it was the same plant, we would have picked the paired t-test. When I hit enter, I get a p-value of 0.0033. This is definitely below the 0.1 and even the 0.05. So again, this is saying that statistically, it indicates that there's a strong effect on the amount of water and growth. Excel, I have that here. So you would look for t-test. And it's going to show you an array. So again, that array here would be, you could highlight the first set of data, click on this one, highlight the second row of data. Your tails, a tail means basically, are you looking at both ends? In other words, could the second group be higher or lower? That's a two-tailed test. Now, if you said in your original that it would be greater, then you could do a one-tailed test. There's not too much difference, at least at the high school level on that. So here are my p-values going through either Excel. So the 6 versus 8 was 0.03, highly significant. 6 versus 10, still less than the 0.05. 8 versus 10, no, that is way high. So students could report the p-value. They would say that is a two-tail t-test, students' t-test. And then they also had 10 plants, or n equals 10. So the other thing would be if we wanted to do a correlation stats, cause and effect. Does more water equal more growth according to our data? So looking at our means here, you could do a scatter plot in Excel. And so we'll show you that. I have some captures there. This is actually something from Fight Like an Animal from Science News. So you could look at this goes up, so that's a positive correlation. The basically correlation says if I drew a straight line, a best fit line, how close are all these data points to that line? And the highest you can get for a correlation, or R squared, is 1. The closer that is, the higher the correlation. But that does not necessarily mean causation. So here is my data. And I did my means. You could do just the data points. That would actually be better. And so once you highlight that, you go insert scatter plot, and you're going to get this. And then once you have that, if you highlight that graph, here's something that looks kind of like a funnel. And from that, you can pick some things. You want a trend line, a straight line. And down at the bottom, you have an R squared. That is your correlation coefficient. So here I get a 0.69, kind of middle of the road. So it's saying there is a positive correlation, but it's not real strong. If you use GraphPad, you still get the same thing. Again, I put in the means. And that is a free app there. So correlation or causation, cause and effect. Some other things you could ask, phosphate levels affect clarity or algal growth. Does age affect reaction time? Those are all some things that you could use to study with your students. There is a website, Free Code Camp, and I put the link there. And they have some different examples that show a strong correlation, but definitely not causation. So it'd be a really good way to explain or discuss those things with your students. So here is our easy at-home experiment. How sticky is the tape? And so that's a basic setup. I'm going to stop sharing this, and I want to actually show you this in action. Okay, so really easy. You need a ruler if you have one with a groove. If you don't have one with a groove, you could use a couple of pencils taped. I have some tape here, any kind of tape. People have tape all over. There's duct tape, clear tape, double stick tape. You could use masking tape. You can get marbles at the dollar store. You get a whole bag of them. So basically, you put your tape, sticky side, you put that, you need a book or a box. And again, the drop is important. And then you measure how far it goes. So it's pretty easy. Have the students do 10 drops for each kind of tape, and then run them through the statistics. Get the mean, do the t-test. You could do the standard deviation, and you could do correlation. If you did, does height affect how far? If you wanted to do some correlation with that. So we're going to take some questions and discussions. These things will all be in the Edmodo files, so you'll have access to those things.